Okay, stoichiometry and chemical reaction / chemical reactions. Okay. So the types of chemical reactions: A plus B goes to C. A plus BC goes to AC plus B. AB plus CD goes to AD plus BC. And then okay. That's kind of the general form that they would write the chemical reactions. So the first one, A plus B going to C. Two elements or two molecules, usually two elements, combined to form a single molecule. What type of reaction is that? That's a what? That's a synthesis reaction. An element plus a compound. So A plus BC goes to AC plus B. What type of reaction is that? That is a single replacement. AB plus CD goes to blah, 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 is a double replacement. Some sort of hydrocarbon reacting with oxygen is a combustion reaction. What are always the products of a combustion reaction every single time? Water and carbon dioxide. Those are always the products. Okay? So this is combustion. Yeah, you're not going to see that. Don't worry. If it has like a sulfur or something like that, you get a sulfur dioxide or something. Yeah. Or you won't see it in this class. So, and the reality is you're probably not going to see organic chemistry until second year at university if you plan on taking it. So I know. All right. So those are the types of reactions. Oh, there's a special type of new double replacement that we talked about briefly. It's a neutralization, right? So it's still a double replacement. There's also a neutralization. What is a neutralization? It's a what, sorry? Yeah, so it's an acid and a base reacting. So if you have NaOH, let's do a simple one, plus HCl, one of the products of a neutralization is always water, right? Because this sodium kicks out the hydrogen and bonds to the Cl, so you get NaCl, and this hydrogen binds to the OH to give us water. So it's always a salt. And when I say a salt, I don't mean sodium chloride. That in this specific case, that is the salt. But a salt is just when you react an acid and a base. That one other compound that's not water is called a salt. Okay, so that's a subcategory of double replacement. Okay, what? Yeah, how to because I'm going to give you a list of reactions and say what type of reactions are these. Okay. All right. Stoichiometry is basically stuff like this. So you have some sort of chemical reaction. You know what? We're going to balance it. So we have NH3, not NH4, plus oxygen goes to NO plus water. And the question is, how many liters of NO, I guess NO is a gas, water is a liquid, oxygen's a gas, and ammonia is gas. Maybe we'll just make them all gases. There we go. How many liters of NO gas are produced when 10 grams of O2 are used? Okay. So I give you this. What do you need to do first? Balance it. You have to be able to balance the reaction. Otherwise, it's useless to you. Okay? So, can you balance that reaction? Yeah? Done? 2, 3? What is it? 4, 5, 4, 6 is what it is. Yeah. It should be 4, 5, 4, and 6. What do you balance last? Just if we're talking about balancing, what do you always try to balance last? The pure one, right? The one that doesn't have anything else bonded to it. It's only one atom. Because that's easy. And you can use fractions and then clear the fractions, right? That's usually combustion reactions. Okay. Always balance the oxygens last. Okay. So we've got it balanced. How many liters of NO gas are produced when we react 10 grams of oxygen? So what's the first thing you write? 10 grams O2, because that's what you have. 10 grams O2. Do we like grams? No, we want moles. How much does 1 mole of O2 weigh? 32 grams, right? Because that'll cancel the grams of O2. Now we have moles of O2, but I don't want moles of O2. What are we trying to do? We're trying to figure out how many moles of nitrogen gas, or how many liters of nitrogen gas. So this is where the balanced equation comes into play. We know that for every 5 moles of O2 reacted, right, we produce 4 moles of nitrogen gas. So that means for every 5 moles O2, we get 4 moles of NO. Okay, the moles of O2 are now gone. But I don't want moles of O2 or NO. I want liters. It's a gas. So what's the number I need to use? 22.4. And I should have said at STP to be specific. All right. So 1 mole of NO gas is 22.4 liters of NO gas, of NO, I'll just say. So then that cancels. And now we have the right units, liters of nitrogen oxide, and we can do the calculations. So going across the top, 10, you always multiply across 10 times 4 times 22.4. I have no idea what that is. Anybody know what that is? 5 points. Oh, yeah, I just want the top. You gave me the final answer. So 896. So I get 896 liters of NO divided by, if I go 32 times 5, 160, thank you. 160, right? And then you divide them. 896 divided by 160 is 5.6 liters of NO gas. Okay? That's kind of stoic. Stoic is like you're given an equation, and you have to balance the equation and then predict products and things like that off the equation. Yes? You have to know what a synthesis reaction is and those types, but I'm not going to be like, what is the definition of? No, I don't like those kind of questions. What do you mean by backwards? Look for the equation. Did we do any of those types? I don't think we did any of those types. Like theoretical versus. Uh, yeah, but that ties into limiting. I'm going to do an example of limiting stuff tomorrow. The only other thing I'd want to talk about today is the energy diagrams. So if you have an equation that looks like this, A plus B goes to C plus 400 kilojoules. What type of reaction is this? Sorry? Exothermic and synthesis. It's a synthesis reaction and it's an exothermic because we're producing energy. So this is an exothermic. So if I ask you to draw an energy diagram, this is going to look like this. If it's exothermic, do you finish higher or lower than you started? Lower, right? So it would look like that, something like that, right? Because this is delta H, right? What does delta H mean? Change in energy. Enthalpy is the actual word. H stands for enthalpy, but that's energy change. And it's always final minus initial. So if the final is lower than the initial, you're going to get a negative value. So your delta H, if I said, what is the delta H for this reaction? Is negative 400, right? You get energy released into the atmosphere. That's why it's negative. And if I want you to label it, which I will, you're going to go, there's delta H. That's equal negative 400 kilojoules. These are your products. These are your reactants. What is this number here? So you're right on both accounts. This is the activation energy, EA, which is so I can actually give you the activation energy and then say label it on the diagram. This thing here, the structure, is the activated complex. Okay, I'm not going to ask you to draw that structure, but that is the activated complex. When the bonds are all breaking and forming kind of at the same time, and then it flies apart and goes to the products. Okay, and then if it was endothermic, this number would be over here, right? So an endothermic reaction would be like 400 kilojoules plus A plus B goes to C. And the delta H, if I just wrote it out, is positive. Okay? Everything else in the diagram is going to be the same except you finish higher. So you write your delta H right there. And the activation energy is that's your activation energy. Yeah. So what is it, catalyst? It just lowers the activation energy, speeds up the reaction, but it doesn't change these things. Okay? So I could ask you, so a catalyst, that's a good question, would just make it look like, yeah, so, come on. A catalyst would look like, the activation energy would look like this. Get a little lower. Amelia. Activation, it just lowers it by a little bit, right? That's it. Okay, so this would be a catalyst. Okay, I think we'll stop there today because that's a lot of me talking. So